This one is very straightforward. As you can see, you have here a cup of the orange and a cup here of blue. That could be, for example, the case of if someone has diabetes, someone does not have diabetes. We are going to see there is a part in which I explain how I show some examples I had created myself on TensorFlow.js. On those examples, you had the one that was more the same. So this kind of problem generally has to do with classification between group. In this specific case, just like our case, we have two variables, but keep in mind that in reality, most of the time you cannot see this kind of because this classification here is binary classification. You have to classify between two classes, so it's relatively easy to do that. But in most situations, we may have a huge amount of class. So how can you classify that? But the specific case is just two classes. Is orange and blue. The meaning of this orange blue can be anything. It can be, for example, if you have diabetes, if you don't have diabetes, could be, for example, if you are span, if they may is not span. In that case, the classification is very easy. They have done that's just a kind of toy model, so you can see clearly there is a line here. So the challenge of the model is how to make this line here. So as you can see here, the neuron has this kind of input here that vary between -1 and 1. So here we have what we call activation function. So have the sigmoid, have ReLU. We are going to use ReLU activation function. Have linear, have sigmoid. Let's use sigmoid. Sigmoid is widely used. The ReLU function was mostly used by deep learning, but anyway, most of my time I have used sigmoid function, or I have used as well the hyperbolic. I think they call it the tangent hyperbolic. I don't remember the name, but they are more or less the same. The learning rate is how fast they are going to learn, but let's leave it as default. The regulation rate, which by the way I can't remember what I mean of that, but anyway, you can look for the L1 the regulation. This part here I cannot remember what the regulation means. Let me see if I can take here. Yes, I cannot remember what's the meaning of regulation. Let's leave it without regulation. But if you look at the internet, most likely you're going to find there are several tricks they use artificial intelligence. Sometimes it's hard to remember how all these possibilities. So as you can see here as well, they have another parameterization as well. You can parameterize the ratio of trained test, which means that let's put like here a value that's more common. We are going to use 8% in our TensorFlow.js model. We have used 8%. So 80% is going to be used for training. If you show here, as you see, smaller the number. If you show, for example, here, as the number is changed, as you can see, the number, because the second one here is the normalization. But let's 80%. So it means that 80% is going to be used for training, and the 20% is going to be used for make sure that the model is not memorized. The model was able to learn what's behind the scene, what's hidden on the data set. So the batch is how long it is. I mean, there are some discussion. TensorFlow.js has this option. We are not going to use that, but you have as well parameterized TensorFlow.js to make a batch. Batch is mean that how much data you present by simulation. We are not going to show it now, but there are some discussion how to have, for example, that can increase the speed of the training because you do not present all the data at once. So the batch is how many training you are going to present before you change the mod. So it can be 1. So I think the mod you're going to oscillate too much because not too much information, just one sample. It can be 10. But there are some discussion which, by the way, I can bring another place about the batch. But anyway, so we are going to use a very simple model. So let's see how it goes. As you can see, the model, the loss function is going to 0, and the classification, the loss is going to be, as you can see, I think it worked just fine. Yes, the loss was almost, as you can see, essentially the model was able to train. As you can see, it separated properly. It separated properly the boundary, separate between orange. Yes, as you can see here, the test is very low, and the training is very low. Testing, yeah, I think it did pretty well. You can keep training if you want, but let's pause it. It was 1,000 Africa, but it converged very fast. You can see here on spot here and spot here, the convergence was very fast. But let's suppose that you take this